Exponential equations, connecting equations to tables. What is the template for an exponential equation? An exponential equation can be written in the form y equals a times b to the x, where a represents our initial value, and b represents our growth factor. In this video, we'll be looking at different exponential equations and generating a table, and then we'll go backwards where we start with the table and write an exponential equation. Problem 1. Here we have the equation y equals 5 times 2 to the x. Before we get started, let's go ahead and identify the parts of the equation. Which part refers to the growth factor? Locating our exponent, we see that the 2 is the base of the exponent, so that this 2 represents the growth factor. Which part refers to the initial value? Notice this constant number 5 that's being multiplied. This is going to represent our initial value. Now that we identified the parts of the equation, let's go ahead and generate a table. Our initial value 5 tells us that when x equals 0, it has a starting point or initial amount of 5. The growth factor tells me as I move down the table, I'm going to be multiplying by times 2. So if I move one row down to 1, if I double 5 times 2, we have the point 1, 10. Moving forward to the next row, as I move down, I'm going to multiply y times 2. So doubling 10 times 2, that's going to be 20. And finally, for the third row, I'm going to continue multiplying by 2. So 20 times 2 is going to be 40. So here we have our table with our initial value at 5. And as we move down, we're multiplying times 2. Problem 2. Y equals 250 times 0.2 to the x. First, let's identify which part represents the growth factor. Locating our exponent, we know that the base of the exponent is 0.2. That's going to represent our growth factor. Now, which part of the equation represents the initial value? Notice that the constant 250 that's being multiplied, this is going to represent our initial value. Now that we identified the parts, let's go ahead and create our table. Our initial value tells us that when x equals 0, we have a starting amount of 250. Our growth factor tells us that as we move down the row, we're going to be multiplying by 0.2 each time. So creating our table, if we move to the first step, we're going to take 250 times 0.2, and that's going to land us at 50. So we have the point 1, 50. Moving to the next row, we know that we're going to take 50 and multiply by another 0.2, and that's going to be 10. And for our third step, we know that we're going to take this 10 and multiply by another 0.2, and that's going to bring us down to 2. So here we have our table that represents the equation. Problem 3. Here we're going backwards. We're starting with our table, and then we're going to write an exponential equation. Let's first identify what's the initial value. Notice that when x equals 0, we're starting with 8, so that our initial value is going to be 8. Where are we going to write 8 in our equation? 8 is going to be the constant that's going to be multiplied on the outside. So our 8 goes there. Now let's go ahead and figure out what our growth factor is. What can we multiply that will help us move down each row? Notice that our growth factor is not going to be a whole number. So let's answer the following question. Starting at 8, if I multiply by the growth factor, what growth factor can I use? That will bring me up to 20. 8 times what growth factor will bring me up to 20? How can I rewrite this expression to help us figure out the growth factor? I can rewrite this as dividing both sides by 8. I get 20 divided by 8. And I see that my growth factor is going to be 2.5. So I see that I can multiply by 2.5 each time to move down each row. Notice that 8 times 2.5 is 20, 20 times 2.5 is 50, and 50 times 2.5 is 125. Notice that since we're repeatedly multiplying by 2.5, 2.5 is going to be the base of my exponent. We know that exponents represents repeated multiplication, and multiplying by 2.5 over and over again. So we have the equation y equals 8 times 2.5 to the power of x. Problem 4. Given this table, let's go ahead and write an exponential equation. Notice that here we don't have our initial value, so let's go and start by figuring out what the growth factor is. How can I move from 18 down to 6 and from 6 down to 2? Notice that to go from 18 down to 6, I'm multiplying by a third. A third of 18 is going to be 6. A third of 6 is going to be 2. So we know that our growth factor is going to be 1/3. And since we're repeatedly multiplying by a third, that's going to be our base of our exponent. Exponent means repeated multiplication. Now moving down, if I'm multiplying by a third, how can I go backwards? How can I move back up the table? We can think of moving backwards as multiplying with our reciprocal. So if we know that our growth factor is 1/3, inverting our numerator and denominator, we see that to go backwards, we can multiply by times 3. So we know that going down, we can multiply by a third, and moving back up, we're multiplying by times 3. 2 times 3 is 6, and 6 times 3 is 18. So what's our initial value going to be? If we multiply by another times 3, what's 18 times 3? We see that 18 times 3 is going to be 54. So we're at 0, we're at 54, so we know that our initial value is going to be 54. So we have the equation y equals 54 times 1/3 to the x. To summarize, connecting equations to tables, we know that exponential equations can be written in the form y equals a times b to the x, where a represents our initial value, which happens when x equals 0, and we know that b is our growth factor, which is going to be the base of our exponent. Exponent means repeated multiplication, so our b is going to be what we repeatedly multiply to move down the table.